Most welcome to 1101. We are beginning a new century. What could be more fitting than to go into the catacomb Iasma Apostolo Paulo. We enter into the most holy of holy sites. Agni Parfene. Oh, sorry. Agni Parfene. I will continue with François-Igor Pris, the man with the difficult name, and it is his article or paper, Heidegger's Quantum Phenomenology, that I will be looking into. It mentions two persons that are very interesting for me. One is Heidegger and the other is Wittgenstein. And on top of that, we have the quantum mechanical philosophy. I will go into it because I previously mentioned it. It's a very, very tough text. So do give it some patience. Even though the language is sort of common, not too technical, the concepts or the ideas or the gestalt, I would say even, it's so alien to normal thinking that it is beyond normal thought. Heisenberg, I'm right into 290 here. Heisenberg distinguished between dogmatic realism, which according to him is the point of view of classical physics, metaphysical realism and practical realism. The latter is the natural realism of science. The dogmatic realism claims that all meaningful affirmations about the material world can be made objective. The metaphysical realism is the dogmatic realism together with the claim that things really do exist. The notion of metaphysical realism, according to Heisenberg, is thus the traditional notion of metaphysical realism. Heisenberg writes that Einstein criticized quantum mechanics from the point of view of dogmatic realism. In reality, however, Einstein's position is much more nuanced. For instance, he writes, "Physics is an attempt conceptually to grasp reality as it is thought independently of its being observed. This corresponds only to the condition 1 above." I need to mention concept once more. That there is an independent objective reality. And second is this objective reality is the reality of objects situated in front of the subject. Although within quantum mechanics the notion of subject and object are meaningful, the ultimate quantum mechanical reality is that of the process of measurement. Very important. The ultimate reality is not subject and object, but the process of measurement. And I will refer henceforth to process of measurement as PM. In which the subject interacts with the object, and in this interaction it is as though both become dissolved, inseparable from each other. And this is of course the Alice and Bob experiment, or thought experiment, where Alice's friend is inexorably connected to the lab where she is doing the experiment. And in the viewpoint of Alice, that is one inseparable unit, and that unit is the PM. And this is more fundamental than subject and object. Subject and object is a randomized take on the PM. So the subject object, if you analyze that, if you measure everything, there will be a lack. That lack will be stochastically measured in quantum mechanics, so you get everything, but not in the same way as in classical physics, where everything is exact, not stochastic. You could say from a classical viewpoint that quantum mechanics is not exact, but what really goes into question is the very exactness in itself. It is not unnecessary, but there is something greater than exactness. Yeah, there is something more important than exactness, and exactness is not sufficient, even though it looks that way. And I would say that looks that way to everyone. This is why quantum mechanics is so exhilarating. Before the measurement, it makes sense to talk about a quantum system situated in a state, for example, in a state of superposition of eigenstates of a physical quantity, of a Hermitian operator, and also about the subject or observer which is independent of the quantum system and does not interact with it. After the measurement, there is also an independent subject observer and a quantum system which is independent of the subject and which is situated in one of the eigenstates of the measured physical quantity. After the act of measurement, the physical quantity has a definite value. The result of the measurement is reproducible, but in the process of measurement, when the probabilistic reduction of the wave function takes place, it makes no sense to talk about the subject as such and the object as such. The process of measurement, reduction of the wave function, cannot be called a physical process in the usual sense. It is unobservable and cannot be mathematized even in principle. The Born rules determining the probability of transition from a superposition state into one of the eigenstates of a physical quantity, i.e. the probabilities of obtaining a definite result of measurement, only establishes a correspondence between the initial situation and the final situation, and does not say anything about the process of transition itself. The principal hypothesis of this paper, in favor of which some arguments are given below, is that it has a phenomenological nature in the sense of the Heideggerian Dasein. Quantum theory can be used as an instrument for preparing a given experimental situation. It seems that this demands more reflection on the foundations of the theory and the nature of reality than in the case of classical physics. But instrumentalism without phenomenology is not an appropriate philosophy of quantum physics. The result of the application of quantum concepts, for example, of the concepts of coordinates and momentum of a particle, is not predetermined. It is false or even meaningless to speak about the simultaneous existence of definite values of position and momentum of a particle, or about the existence of a well-defined trajectory of a quantum particle. Quantum concepts are rules, operators for obtaining definite values. A definite value appears only as the result of an application of a quantum concept, that is, as the result of measurement. For example, if the momentum of a free particle has a definite value, its position is absolutely undetermined. In this case, the result of an application of the concept of a coordinate is absolutely undetermined, though quantum probabilities are determined. The coordinate with equal probability can take any value. A definite value appears only as a result of a process of measurement of the coordinate. How great it feels that even before I read it in the introduction, I sort of nailed it. I'm not here to further myself or make myself bigger, but there is a grand pleasure in getting into the things. It's very pleasurable because our course doesn't follow any tests, so there can be no outside gratification, but I do get the inner gratification of now I understand it. Really happy I was so stubborn with continuing. Classical commutative physical quantities represent some real numbers. This cannot be said about the corresponding quantum operators. For a given quantum state, they represent matrices. That is, sets of possible values of a physical quantities together with the corresponding probabilities. The actualization of a given definite value happens during the process of measurement. One can say that quantum concepts of physical quantities represent some quantum physical quantities, properties, which should be understood as dispositional ones. One could say that representation of a quantum property has no analog in quantum mechanics. A quote from Suarez here. There is no analog of this type of presentation in classical mechanics. A quantum state is not to be interpreted a la classical mechanics as assignment of actually possessed properties and their values, but rather as mere assignment of probabilities. Although before the measurement of the position of the electron does not have any definite position, one cannot say that it does not have any position at all. The position of the electron, given its wave function, is a real dispositional property, which is described by the operator of its position. That is why for Heisenberg, the atoms of elementary particles form a world of potentialities or possibilities rather than one of things or facts. Do not think that the fundamental is true facts, momentum and position. The potentialities are the fundamental. That's a thought mistake I've been doing for 30 years. This is made clear with the text of François-Igor Pris, but it has also been very helpful to go through Paavo, Pylkkönen, and also Bitbol. I'm going to take a lecture of Bitbol tomorrow or the day after tomorrow. In spite of its revolutionary character, the theory of relativity, special and general, is considered as a classical theory precisely because the concepts used by the theory and the theory as a whole function in the classical regime. The observer measures the quantities whose concrete values exist before the measurement, though they depend on a reference frame, i.e. independently of whether or not the observer produces a measurement. The Einstein principle of relativity, saying that there is no privileged physical framework. Different observers observe different values of a physical quantity, does not take into consideration the relativity of the border between the observer and what is observed. In quantum mechanics, this border is fixed only post factum, as a result of the process of measurement. Post factum, after the experiment of the friends of Alice and Bob's, a classical concept and the corresponding quantum concept can be understood as two aspects of one and the same more general concept. According to Mark Wilson, even simple concepts have a rich internal fine structure consisting of subconcepts related to each other in different ways. Some concepts function as an atlas consisting of various partially overlapping leaves, maps. Here is one of his examples cited by Robert Brandon. Some concepts, yes. Mass, impressed gravitational force, and work required to move something relative to a local frame are some of the leaves of the atlas structured empirical concept weight. Some of the leaves, not all of them. In the case of the atlas structure is a Wittgensteinian family resemblance between the different leaves of an atlas. A more complex conceptual structure is the patchwork one, proposed by Wilson. The various leaves in a patchwork are connected to each other at their edges. Such is, for example, the concept of hardness. Brandom described this example as follows. Hardness generically is something like resistance to penetration. To test such resistance, we might press a weight on a sample, squeeze it, strike it, scratch it, cut it, or rub it. The result of these various tests will not always be conciliant. The generous concept of physical quantities representing classical as well as quantum properties can be understood as atlas patchwork swans. The domains of application of a classical concept and the corresponding quantum concept are overlapped when the physical quantity has a definite value. His understanding of the relation between classical and quantum concepts is somewhat different from our own. I need to put a note here. Your way of understanding, your understanding function is always in classical mood. This you have to start with. There's no other starting point, since we don't think in quantum ways. Therefore, we will automatically think of the inexactness, as we believe, of quantum physics as an inexactness. By training only we can get away from that. And that's not a regular training. This is a whole body retraining, because the exactness idea or the exact gestalt is more in our bodies than it is in a sort of abstract thinking. The wave function and quantum reality. Let us illustrate the question about quantum reality, quantum objectivity, and quantum concepts by using the example of the wave function. It is known that the wave function suffers from the lack of objective reality in the following sense. A wave function can be determined in a statistical context when there is the possibility of performing measurements on its identical copies. If one deals with only one exemplar of a quantum system situated in a pure state psi, which is an eigenstate with the eigenvalue 1 of a projector, the function psi is known only to the experimenter who prepared it, but cannot be known to an exterior observer. Indeed, if an observer performs a measurement, the system modifies its state irreversibly and randomly. A part of the information about the initial state of the system is lost. The experimenter obtains only partial information about it, and as a consequence, it is impossible to copy exactly an unknown quantum state. This is called the non-cloning theorem. And this is the same as I said before. Every making of each silicon chip is unique. That defies our normal understanding, since we normally think every IKEA table or every car is the same to some extent. Hence, one should either accept the existence of unknowable reality, unknowable from the point of view of the observer, who is not implicated in the process of preparing the wave function, or recognize that the ultimate reality supposes the presence of an interacting subject-observer. Independently of the observer, the quantum function cannot be considered as objective real. The quantum reality is the reality of the act of preparing the state of the system. In the last case, the concept wave function cannot be viewed as a concept in the classical sense, but as a quantum concept, whose functioning supposes the presence of the observer. In substance, in quantum mechanics, concepts are functioning not as means for representing a metaphysical reality of objects, existing independently from the observer, but as rules for the interaction of the observer with the reality, for the formation of the classical metaphysical reality, which is secondary by the observer. Hence, the understanding of quantum mechanics should not consist of understanding quantum concepts in a classical way, which is not possible, but in understanding that such understanding is not possible, that quantum concepts differ from the classical ones in the way they function. What has been said agrees with the following position, which Wilson attributes to Kant. The general claim is that our naive conception of objective concepts as corresponding to real-world attributes is incoherent, that every viable concept must inherently involve the constructive agencies of our own minds in some irrevocable way. End of quote. The measurement problem, the hard problem in the philosophy of mind, and the Wittgensteinian problem of rule following. Let me just add something here. There is a naivety to think that if the outside world remains the same, we can somehow change our inner world. And that is absolutely impossible. Only with the change of the outside world, the exophysics, can an endophysics be achieved. If the outside world remains the same, there is no change in the endophysics. This is the lesson from Wittgenstein, and I would say that's the most succinct, short way of describing what Wittgenstein did. If you have a certain exophysics, this is when you get the hard problem in the philosophy of mind. Isn't that interesting? If two people, and this is, if two people share the same physics, they do share the same way of thinking. That's the tricky thing with the old physics, and that already started with the Milesian. And this is what Heraclitus tried to get around, or did get around, I would say. He is the only true philosopher in my mind. Well, before Heidegger and Wittgenstein. The act of measurement, action of the subject in the process of measurement, is being performed within an established scientific and ordinary practice, in accordance with implicit and explicit rules. That is why it is impossible to dissolve the measurement problem pragmatically. Michel Bitbol, for example, proposed the Wittgensteinian dissolution of the measurement problem within the second philosophy of Wittgenstein, without making an appeal to Heidegger's philosophy. The dissolution consists of using the instruments and mathematical symbols in a way so that the problem no longer appears. This is not a naive avoidance of attempts to solve the problem. The Wittgensteinian dissolution of the problem is the initial point, but also the final point of a long series of failed attempts to solve the problem formally or discursively. Bitbol emphasizes that the quantum observation is not an observation of pre-existing entities. It is a practice organized according to procedural rationalities guided by theoretical rules. The ontology in the sense of Quine is a secondary retranslation of this practice. The act of measurement is an execution of procedures which, for a certain class of well-defined experiential preparations, gives reproducible values. These values can be treated as secondary, as reflecting properties of objects. According to Bitbol, the function of I is to manifest an engagement in the double sense of this word. Engagement to accomplish something and engagement in a situation. The formalism of quantum mechanics taken in isolation from the practice of its application is incomplete, and a form and completion of quantum mechanics is impossible. Nevertheless, says Bitbol, a larger system including the quantum formalism, the probability rules of its application, and its effective confrontation with the achievement of every concrete experiential situation, has been complete since the creation of quantum mechanics. And listen very careful. This is a performative completion, a performative completeness. Things cannot be complete without performance. In the very measurement problem, the PM, if you want, that is when it happens. Not in something action-independent reality. And also that doesn't make any sense from Gibson's side. Doesn't make any sense when you think about it very sharply. It defies sense, although it never defies common sense, because this is well established in common sense but not thought through. So one could say quantum mechanics is a thinking through things, looking at them. In this regard, they resemble to some degree, not all degree, but to some degree, the careful reading of Jacques Derrida, or what a lawyer can do with the law. He does not only read the law book and all the predicates carefully, he also think it through. And that's the work of both the judge, the attorney, and the lawyer. And of course the prosecutor. This is why I think the Swedish justice system is horrendous. Because if you sit in the same table, you are bound to make the same conclusion, no matter if you're against it or for it. This is a... I don't even have a word for the Swedish judicial system. It is absolutely 100% classical physical, metaphorical assumptions. Though at first sight no two philosophers are more different than Heidegger and Wittgenstein, there is no doubt that both are pragmatists. Brandon, for example, understands Heidegger's philosophy as a normative pragmatism. The normative social practice is primary. Norms and rules are implicit in the practice. Phenomena, objects, and the subject herself are secondary. They can be reconstructed pragmatically. One can agree with Rouse that Brandam's anti-naturalistic interpretation of Heidegger should be turned on its head. Heidegger is a naturalist. Natural phenomena are primary. They contain in themselves their own implicit norms. Very good. Listen to that. They contain in themselves their own implicit norms. Rules within them, not exo-rules. The rules are within. You see here how the classical physical rules, or the rules of the law system, are exogenous somehow. Quantum mechanics point to internal rules. This is the same thing as we done before with time and space when it comes to knowledge. We usually say that knowledge is outside in some way, exogenous, like the rules of the universe in the classical mode, like Hawking, or why not the genetic understanding of Richard Dawkins. They seem to be inside the genes, but the rules regulating the genes, according to Dawkins, are outside. So we can put them on paper, we can observe them, we can state them, we can claim them. Something that was destroyed by the American multi-billionaire when no single origin could be proved. But what I'm pointing here to is that the rules are exogenous. They're outside somehow. Only. The only is the most important here. The Wittgensteinian language games, governed by the implicit or explicit natural rules, are both natural and spontaneous. Moreover, there are some reason to think that Heidegger's metaphysics is implicit in Wittgenstein's philosophy, and the Heideggerian notion of Dasein corresponds to the Wittgensteinian notions of language game and form of life. For example, the following characterization of Dasein is also applicable to the language games. Dasein is an entity which in its very being comports itself understandingly towards that being. Dasein exists. Furthermore, Dasein is an entity which in each case I myself am. Mineness belongs to any existent Dasein and belongs to it as the condition which makes authenticity and inauthenticity possible. Heidegger needs in a special technical philosophical language to theorize the background, the practices, according to Dreyfus. In other words, Heidegger's phenomenology makes explicit what is implicit in multiple Wittgensteinian examples. The philosophical literature indicates the existence of a close relationship between the notions of language game and form of life and Dasein. Heidegger himself writes that language is not identical with the sum total of all the words printed in a dictionary. Instead, language is a Dasein is. it exists. This is why one can suppose that together with the Wittgensteinian notion of language game, the Heideggerian notion of Dasein can be used for pragmatic phenomenological solution of the measurement problem in quantum mechanics. To be more precise, the notion of language game rather allows a theoretical dissolution of the measurement problem. The notion of Dasein allows an explicit metaphysical solution of it. The theoretical rules used by subject-observer for explanations and predication of quantum mechanical phenomena and the real material quantum mechanical system, the things rules are being applied to, are two complementary aspects of the functioning of quantum mechanics. During the process of measurement, one or another possibility is being actualized. The gap between the phase of a theoretical prediction and the phase of asserting a result of measurement, that is, between the domain of possible and that of actual, is being closed pragmatically. Hence, the measurement problem can be understood as an instantiation of the Wittgensteinian problem of rule following, or as the problem of gap between the quantum mechanical rules or concepts and their application, where the role of the quantum observer, thus of consciousness, is significant. This problem can be solved or dissolved a la Wittgenstein. The process of measurement is a Wittgensteinian process, a language game of the application of quantum rules. The so-called explanatory gap problem in the philosophy of mind, which is also called the hard problem of consciousness, that is the problem of physicalistic or naturalistic explanation of a phenomenal consciousness, can be understood as a Wittgensteinian problem of a gap between a rule concept and its application. Hence, the measurement problem in quantum mechanics is an instantiation of the explanatory gap problem, or the hard problem in philosophy of mind. The existence of different kinds of dualistic solutions of the measurement problem, the affirmation of that reduction of the wave function, is due to the consciousness of the observer, or on the contrary, that it generates consciousness. The Wigner solution of the measurement problem, which makes appeal to the consciousness of the observer, the many-mind solution, and so on, indicates that it is necessary to take consciousness into account. At the same time, it is a consequence of a reification of consciousness, which is not a nothing, but not a something either, a paraphrase of the Wittgensteinian claim about sensations. According to Bitbol, Wittgensteinian idea is that consciousness should be taken as an immediate experience rather than self-awareness. Sie ist kein Etwas, aber auch nicht ein Nichts. Although Wittgenstein speaks about sensations. For him, this is also true for consciousness in general. Just put some more. Consciousness must be included in quantum mechanics and physics in general, not as a non-physical substance or non-physical properties, but as a primary given, an immediate experience which in itself is physical. This is the beginning and the end of a theory. The immediate experience closes the explanatory gap between a theory and its application. The hard problem in the philosophy of mind, or the problem of closing the gap between phenomenal consciousness and its physicalistic description, appears as a result of reification of consciousness. It can be solved or dissolved only by means of a correct understanding of the naturalistic, physicalistic nature of consciousness. So briefly, the logic of a pragmatic dissolution or normative naturalistic solution of the measurement problem is the following. 1. The measurement problem is a particular case of a more general problem, the hard problem or the problem of the explanatory gap in the philosophy of mind. Michel Bitbol writes in 2000 that the measurement problem and the hard problem have one and the same structure. Eureka, I would say. A human being, and thus consciousness, is essentially involved in the process of measurement. A human being forms an intention to accomplish a measurement and accomplishes it, and finally observes the results of measurement. 2. The hard problem can be reduced to the problem of application of a rule, concept or theory, in the Wittgensteinian sense. The explanatory gap is a gap between a neurological concept describing a phenomenological experience and its application to the phenomenological experience. Hence, it is also a gap between a neurological concept and the corresponding phenomenological concept. 3. The act of application of a rule is a Wittgensteinian language game. Within the language game, the explanatory gap is closed. Four. The notion of language game can be understood not only pragmatically, that is, as a normative activity, interaction or practice, but also naturalistically, that is, as a natural phenomenon. The language game is both natural and spontaneous, that is, normative. Hence the Wittgensteinian naturalism is not metaphysical but normative, which means that the phenomenon contains in itself its own implicit norms that are themselves natural. The corresponding notion in Joseph Roos is phenomenon or interaction. According to Roos, we should stop conceiving of the normative and the material as separate. The two are constitutive of each other. Five. Heidegger's notion of Dasein corresponds to Wittgenstein's notion of language game. Thomas Wrench, 2003, thinks that Dasein Five. Heidegger's notion of Dasein corresponds to Wittgenstein's notion of language game. Thomas Wrench thinks that Dasein corresponds rather to the Wittgensteinian notion of form of life. However, the Wittgensteinian notion of a form of life can be understood as a system of established language games, background, or as a sort of language game of the second order, within which it only makes sense to consider more concrete language games of the first order. 6. The so-called collapse of the wave function in the process of measurement is not a physical process. The process of measurement in quantum mechanics is a Wittgensteinian language game, or in metaphysical Heideggerian language, Dasein, or a realization of one of the possibilities of Dasein. Notice in this connection that Elan, 2004, within his phenomenological interpretation of the measurement problem in quantum mechanics, claims Husserl's noetic-normatic union of subject and object is an entanglement between the intentional subject and the emergent object, similar perhaps at this stage to Heidegger's Dasein. End of quote. The understanding of the nature of the process of measurement. This allows a therapeutic dissolution or a metaphysical solution of the measurement problem. Conclusion. Heidegger's phenomenology, as well as the second philosophy of Wittgenstein, can be understood as a normative pragmatism and even as a specific normative naturalism. It makes explicit the metaphysical presupposition of the second philosophy of Wittgenstein. Both philosophies are appropriate for understanding quantum mechanics as a science of a new type. Rejecting the metaphysical notion of reality and for solving, in the case of Heidegger, or dissolving, in the case of Wittgenstein, the measurement problem in quantum mechanics. Quantum concepts function rather as rules for forming a new reality, not as notions for describing a pre-existing metaphysical reality which is independent from the observer in absolute sense. The measurement problem in quantum mechanics has the same structure as the hard problem in the philosophy of mind, and can be reduced to the Wittgensteinian problem of rule following. The gap between the potential possibilities theoretically described within quantum mechanics and the actualization of one of these possibilities is being closed pragmatically within the language game of a correct application of quantum mechanics, playing the role of a Wittgensteinian rule. In the theoretical metaphysical language of Heidegger, the language game is Dasein, or a realization of one of the potential possibilities contained in Dasein. The addition of this philosophical notion to the notional apparatus of quantum mechanics allows a theoretical solution to the measurement problem. And I would mention some interesting bits here. J. Roos from 2002, How Scientific Practices Matter. I will get back to him. And also Bitbol, Physique et Philosophie de l'Esprit, 2002, Bitbol, Science as a Situated Matter. I will contrast and comment this with the use of our old friend This is from Diego Lucio Rapaport, and this is about workings of a space that is not dislocated from the subject. Remember the Klein bottle. Klein bottle shows that space in itself is always an interaction with subject and object. This should not be understood as there is a subject in space. It should be understood that subject is participatory in space. Now read here, I got a PowerPoint here. It has to do with non-orientability. As we gone through earlier, and it was like 500 episodes ago, so it's well worth mentioning again. It appears as the completion of space or space-time dislocation, which closes a fractured cycle taken around a singularity, thus blending self-reference to produce the closure of the path of a singularity, and the heteroreference as the altar of singularity. the two fundamental cognitive principles. Torsion thereby stands as the fundamental geometry of physics, for which cyclic processes are the most fundamental and which are associated with torsion through spin. Remember the spin of the electron. Particularly quantum physics, the fundamental interactions, fluid and magnetohydrodynamics, the most pervasive form of matter in cosmos, biology, chemistry already in the chemical bond, and through the morphology of molecules in the topological chemistry paradigm, and in the Klein-Bottle form of the Mendeleev periodic table of elements, which is the unfoldment of the golden spiral and of the standing wave. This is fundamental to perception and cognition, and crucial also for music. Torsion has been related to another notion with plural naming, that of quantum anholonomy. Berry phase, quantum phase, or still geometric or topological phase, which we discuss below. We already presented as the Möbius strip, i.e. a topological phase, the torsion of a dislocated crystal, the primal form of anaholonomy of space or space-time, or still in the projective space of quantum mechanics. Let's go into the Berry phase, or the holonomies, or the anholonomies. An introduces a contradiction. It shows that space in itself is contradictory. Space and no space participate to make space. Suppose we can transport the system of a self-referential, i.e. closed path in the abstract space of states, to further discover that the fact that the state variables return to the initial values and that there is no local rate of change for quantity. However, it appears there is a global change in A values at the end of the closed path in the complete system of states. Thus, in manifest physical appearance, there is a difference with the initial state of returning to it through a closed loop in state space. This final state is called the anholonomy, or alternative anholonomy. Two observations are in order. Firstly is the notion of transport. More precisely is of parallel transport. In what is being transported, say a state of a system or a vector in space-time, say a crystal. As in the introduction of torsion is through a rule which allows to define transport objects as keeping them parallel between them, so it is a relational construct. Secondly, a cyclic character about which the transport is carried or itself brings the issue of cyclicity, as in the case of torsion. Thirdly, the ultimate cognitive operation is of establishing a difference, and furthermore, Secondly, a cyclic character about which the transport is carried or itself brings the issue of cyclicity, as in the case of torsion. Thirdly, the ultimate cognitive operation is of establishing a difference, and furthermore, second-order differences arising from the primal ones, and it is the second-order differences which allow for meaning and understanding, as proposed by the cybernetist Gregory Bateson. Torsion is the primal geometric and holonomy, non-orientable Möbius strip, and we have already shown this to be the case with the torsion providing the closure of a path around a singularity, and certainly in the Möbius strip where the path is also longitudinal around the singularity, and is the very basis for the protoform of Newton's third law. Conceived as an anholonomy, Newton's third law is that when two bodies interact contact-wise, they apply forces to one another that are equal in magnitude and opposite in direction. When we take a vector perpendicular, aka normal, to the surface at some point of the Möbius strip, points upward, and we further translate this vector to the same point as placed on the other side under the Möbius strip after 360 degrees per course completing. Thus, half a closed path, the perpendicular vector now points downward. It takes another longitudinal transfer with 360 degrees rotation to return to the original state. I think this shows also the electron spins, 2 turns to get back, and those are not 2 turns really. This is because we are so imbibed or primed with classical physics, so instead of really understanding what's going on from a diminished perspective of the illusion of exactness, which is actually an obstacle to understanding, to knowing. Exactness doesn't have anything exact with it, because of the observer everything changes. Exactness can be exact in some cases, but not in others, but you will not know when it is exact or not exact, because the subject needs to be in on it. Subject is part of space. It is not something observing space. It is not situated in space. None of these so-called solutions hold for quantum mechanics. And when we say we are situated in space, that doesn't make sense. There is not 2 different spaces, one 3-dimension XYZ. No, it is just that we don't think things through. Like we stick our hand in a hole that we shouldn't have stuck in it. And when someone asks, why did you do that? We don't have any explanation. There can be no answer because we didn't think before we did it. So one could call classical physics a very, very quick instinctual reaction to say something, and that is not thoroughly thought about. Given a point on the vortex as the center of coordinates, would we consider the radius vector from the center to the point of the surface? Then after a complete 360 degrees rotation, the radius returns to the same point, but the normal vector does not. This is called the anholonomy of 360 degrees of the Möbius strip. Another complete turn of 360 degrees will complete the path to close it and yield the same upper pointing vector. Möbius strip is in this case of topological anholonomity and is founded on physical configuration space terms, not a state space, which nevertheless can also be taken as the case. Indeed, this state space is given by Möbius strip and the normal vectors to it. And the normal vectors to it, and the parameter space is subsumed by two values, +1 and -1, describing the upper pointing and downward pointing direction of the perpendicular vectors. To resume, the Möbius anholonomy as a non-orientability can be described both as a real configuration space property or one arising rather than being limited to quantum physics. Quantum anholonomies have been elicited in optics, electromagnetic systems, electric signals, filtering devices, electromagnetism, acoustics, gravity waves, fluids, nanocrystals, metamaterials, optics, etc. Furthermore, this historically was in unacknowledgement of the relation between dislocated crystals of the quantum fluctuations of the vacuum as elementary examples of torsion geometry, revealing the unity of continuity and singularities as discontinuities, and quantum anholonomies, and still the fact that topologically these torsion geometries are undissociable from the non-orientability of nonlinear vortical processes, be that in state space or configuration space or space-time. Separately, the torsion geometries of Brownian motion, fluid and magnetohydrodynamics, quantum physics, statistical thermodynamics, as state space or space-time configuration manifolds, which was revealed independently of the notion of Berry phase space. I have to add here, non-orientability is in the viewpoint of an assumed classical physics with x, y, z. But do you see now how you can only be oriented in space starting with yourself, because this is how space is constructed. And someone commented when I showed the Klein bottle once upon a time, he said the true face of the Klein bottle cannot be presented, and I said yes and no. I didn't want to sound like Yoda or anything like that, but the reason was that there is no truer Klein bottle in the fourth dimension, as a classical physicist would assume. It is true as it is, because you cannot see space from outside. So A, the regular space, we have the belief you can see space from outside, and therefore we could potentially put in the Klein bottle in that space, and then you can realize it is not accurately depicted because the Klein bottle is in 4 dimensions. B, dimensions begin with the subject. This is what the Klein bottle shows. Therefore, it is an accurate depiction of how space works, but it's not accurate from a potential idea, many worlds idea it is, because 4th dimension in that way is a big misnomer or an impossibility. So this is true space. Klein bottle is true space, whereas also the Möbius strip shows how space works. Now you might realize the utter importance also for geometry, mathematics, physics, the real world, why you need to orient yourself from an inner rule, from an inner measurement. If you don't do that, you will not be localized at all. It's your up, it's your down, it is your right, it's your left. What you stand on is incredibly important. And saying it's not important, it's like saying, it's not really important that I have air to breathe, or it doesn't matter whether I'm in water or outside water with my head. It's a little bit like saying brain in the vat is a possibility somehow. Or as Descartes saying, I can dislocate myself from my body and just be thinking. It is sheer nonsense. This is not quantum space, neither is there any space that ever existed. Another question could be, can we really understand this space? The question should be stated, can we understand space? What I'm trying to show here by the help of Rappaport, this last part of the lecture, is we are not oriented in space. We are blocking out space. It's a hidden assumption somewhere, or a gestalt, that space is not important. We can just think ourselves out of this situation without knowing how we are, what we're placing our feet on somehow. This is absolutely 100% absurd. We can add to this universal phenomena of resonance or harmonic systems, which has non-orientability and quantum and holonomies at the very basis. It has been empirically verified that resonance arises from tuning harmonic systems through the mediation of non-orientable states in state space, which exist in so-called exceptional or diabolical states. If wished, a virtual or abstract non-orientability, a transference of energy does take place, the resonance is in effect. Remarkably, the Möbius strip and Klein bottle can be characterized as either real space and holonomous, or state space, abstract or virtual, and holonomous. In cybernetics, general systems theory, and the foundation to biosemiotics, in his Steps to an Ecology of Mind, Bateson envisaged the existence of a universal transcendental metaform, a pattern which connects. Thus we identified Möbius strip and Klein bottle non-orientability as the generic metaform of connection by resonance metapatterns. The Klein bottle as a metaphor for pattern formation, with or without a subjective agent, and pattern recognition versus such an agent. It appears as the dominant first and second order spherical harmonics decomposition of a sinusoidal, thus periodic signal. In pattern recognition appears through the statistical studies of digitalized photographs of nature. This is on neural activity as well, and it comes into a chapter here that shows that it is very important for our understanding of the visual, and this is very close to what I mentioned the other day about polarized light. Polarization is the true understanding of knowing of a probe moving, not location in XYZ or the motion T. I heard an example the other day. Somebody described a movement in the way of XYZ and moving of different things to different position. Example, moving that tree or cutting it down and putting it over there. This is trying to put things in a phase space that doesn't exist. It is a non-knowing. Space is never exempted from the subject. Trying to do that might succeed to some degree in very limited cases, often cases that we define as being of classical mechanical nature, but that will never work in the rest of the 99.9999 situations that we encounter as human beings. So that's the worst possible example. Space does not work that way. We can make it work when we build a bridge, make a house, but those are so extremely limited cases of reality. So you see here, the idea of orienting oneself from the outside is disastrous to position, posture. It will provoke the building of T2 muscles directly and to neurons directly. Your whole system goes into alert, and also the visual system gets madly defected. We are no longer good with seeing any longer, because this affects the neurons that are close to the retina at the back of the eye, and also that is the processing through the optical nerve. So the effects are to be seen everywhere, and they are all built in the same way. The Klein bottle is not one object, specific object, it's all of space. It's the build-up of neurons, it's the build-up of how you see. And trying to see in a Newtonian way, it is just taking away randomly a bit of the information and blocking out, and this blockedness, this non-knowing, this lack of consciousness is what you later called Newtonian understanding. It could be enough for some positions, but it could really not be enough for all positions. You get stuck in the state phase, in the state space, a static space. That stuckedness is always muscular. That change in your body will make you believe that you perceive three-dimensional space somehow, where you are an object in that space, or subject looking at the object. And then you take like snapshots, like Bruno Leschi and his Camera Oscura in Florence all those years ago. And then you can come to a painting that is made to be unspecified, non-localized, and you say that is a piece of reality. If you believe that to be reality, your body is already in bad workings. It doesn't function properly because you're no longer situated in space. You don't have a subjective up, so to say, because this is both subjective and objective. It's like the Möbius strip. It's the perpendicular position here or the perpendicular position here, and you need to go 360 degrees one time, two times to go back to the same place. The Möbius strip and the Klein bottle are not exceptions. Having a map or a three-dimensional depiction of reality, that is the exception. And it's an incredibly small exception. I would say if you're not an engineer and excessively working with things that are connected to first drawing and then directly making something, it would be a very, very unusual circumstance in any case. And if you're a layman, you will never have to deal with it ever. But still, all of the population do it, and we get these shadowy effects like determinism, or the subject being outside of the world, as in the case with Tegmark and Hugh Everett, or that you are a subject in space looking at objects, and those objects gets reified and permanent somehow. All our perception is moving. Any static perception is not of the world. It doesn't even mean anything from a neurological perspective. Seeing as something and you don't know your motives, you lost 80% of the information, and the rest 20% is absolutely by happenstance. It will not be enough to have an understanding of the movement. There is no such thing as static perception. That's my way of describing this from a neurological perspective. I hope it's helpful. Yes, this was a very difficult lecture, and I think it's time to end it before it gets even more difficult. I say thank you very much. It was a pleasure. I'm glad to have a déjà vu or rendezvous once more with Diego Lucio Rappaport. It would be very interesting to meet the man over Zoom someday, but it is still very hard to accomplish that last thing. But thank you anyway, Lucio Diego Rappaport. And have a very pleasant afternoon. Bye bye for now.